Hello, my name is Jim Walters, BICSI U.S. South Central Regional Director. Thank you for joining us for how I decided which technologies solutions to promote on billion-dollar scale healthcare projects. Our presenter is Kevin Chung, RCDD. Kevin is a professional engineer with over 30 years of experience in many disciplines. He has worked on hundreds of building projects, including as owner's engineer for the three largest hospital redevelopment projects in British Columbia, Canada. He has been a member of various code and standard committees, including the BICSI Standards Committee and Code subcommittees. Kevin was the 2017 recipient of BICSI's Ross G.H. Cotton Canadian Region Award. Ladies and gentlemen, please welcome Kevin Chung.
Hello, everyone, and thank you for attending this session. Today, I'll be presenting on how I decided which technology solutions to promote on large projects, primarily healthcare related, but also other similar complicated projects. For today's agenda, I'll touch on a bit of a personal introduction. I'd also like to explain the purpose of this presentation and the intended audience. I'll also touch on prior presentations I've done to give people a bit of context around this particular presentation, such as I'll be touching on some of the implications of Canadian codes and standards and why they matter in this context. I'll talk about how I balance competing factors and interests on the projects that I worked on because they obviously factor into how we end up picking what we pick. Another thing that I'll do is I'll give some actual examples of some of those technologies that were selected, and then I will summarize with a bit of an overview and some pointers. So first off, the personal introduction. I have more than 3 decades of electrical engineering experience, generally on large and complicated projects across North America, Canada, the US, Bahamas, Bermuda, and projects like hospitals, airports, prisons, and remotely supervised transit stations. They all have similar levels of complexity, as do some of the industrial facilities that I've worked on. So I've worked in a leadership capacity on several multi-$100 million projects as well as billion-dollar projects. Locally, such as Children and Women's Hospital, Royal Columbian Hospital, St. Paul's, but I also worked on projects like the airport in the Bahamas and the hospital in Bermuda. Carrying on with the introduction, I was the 2017 recipient of the Canadian Region Ross Cotton Award. I work on several codes and standards, including American ones. I'm not currently working on any major projects. Basically, I just kind of don't need to do that kind of stuff anymore. I do freelancing and I do sub-consulting because I have my own corporation. My preferred work is actually legal expert witness work because I've become very specialized. The last 3 years, I've been doing electric vehicle charging along with the freelancing. So the purpose of this presentation, what I wanted to do when I was looking at a lot of the documentation I saw was to assist salespeople in understanding my perspective, because they often struggle to try to convince me of things. And as a result, I think it's worthwhile helping salespeople and other engineers that might end up in situations like myself in understanding, how I did it and why I got so many large projects. but also helping those salespeople understand my perspective and the perspective, hopefully, of engineers like myself. So prior presentations, I've done several presentations within BICSI, primarily on codes and standards at conferences, regional meetings, etc. But I've also done them for the Canadian Healthcare Engineering Society. I'll be doing another one. I did one recently. I'll do one next year. Primarily, I present on codes and standards, but I also do other topics such as risk assessment. I've done ones for sustainability, including for BICSI, obviously electric vehicle charging, but also very esoteric technical topics like the elevator code. Therefore, this presentation is a bit of a departure for me. I say that it's very similar to when I used to teach in night school. You know what they say, those who can't do, teach. On the subject of the codes and standards, and as I mentioned, the bit about Canada versus the US, I often find salespeople presenting what I call a canned presentation that was prepared in America, but they're trying to present it in Canada. And they don't realize that references to codes and standards like NEC, UL, NFPA, they're probably not going to be relevant in Canada because we have our own equivalents and they're very similar, but they're different. So I tell people it's a common misconception that Canada is like America's backwoods cousin. And, you know, if something works in America, it should automatically work in Canada. The reality is actually quite different. And one of my prior presentations did actually compare Canada to the US and how they're different in terms of references. One of the projects that I have worked on and I continue to work on is actually proposing changes to the NEC because I am familiar with it. As well as other harmonized bi- or tri-national codes and standards, because some of our codes and standards are actually harmonized all the way from Canada, US, and Mexico. So what I try to tell Americans is to consider Canada more like California, in that we basically have one set of codes and standards for a similar size population. Whereas I find America is a patchwork of different versions of codes and standards. And then, you know, when I worked in the Caribbean, they also tend to use American standards, but they're not necessarily the latest ones. So in the context of hospitals, the reason I may come across as a bit of a tough sell for salesmen is when I have to design the electrical, communications, technology, lighting, and etc. Systems, I have to consider hundreds of things. So for example, you know, how the utility power is done, how the emergency power is done, how the UPS power is done. And in terms of the technology systems, you know, how the fire alarm will be done. We very often have like a little mini data center. We obviously have the structured cabling, wireless networking, a whole pile of different communication systems. And I have to consider all of those simultaneously, as well as, you know, things that are kind of less technology, but sort of communications, like the telephone system, the intercom system, as well as things like access control, etc. Then I also have to think of the hospital-specific aspects of those systems, because obviously in the context of a hospital, it's different. And they have a lot of different departments with a lot of different needs. So, and then I'll have to do all of that with a finite budget and dynamic requirements and priorities. So what I often tell people is I have to be super detailed. So some other types of projects that are similarly complicated from a technology perspective are things like light rapid transit stations. So here in BC, our trains are unmanned, so they're centrally controlled. So as a result, there's a lot of remote sensing and control. And these projects can easily also exceed $1 billion, but it's important to understand that most of that money is actually in the guideway. It's not in the stations, although people see the stations, and like this one, Brentwood, they look really nice, and obviously they're not inexpensive. The majority of the cost is actually the guideway because it has to go so far. So we have many technology systems, some of which I've listed. So guideway intrusion, ticket vending machines, ticket validator units, all these types of things, CCTV, of course, because when you're remotely monitoring these stations, one of the things that they're concerned about is trips and falls. So we have extensive CCTV on things like the stairs and escalators, because of course that's where people are most likely to trip and fall. And they want to make sure they have a record of that. They obviously also have CCTV on the guideway because, you know, we have issues there as well. And so therefore we have mechanisms to allow people on the platform to communicate with the central operations. And the power configuration for these is also very different from facilities like hospitals because they don't generally have emergency power backup. They usually have redundant utility supplies and perhaps UPSs on critical systems. So, and in the context of BC, the staffing and the staffing ratio and the population of a station is very different, very heavy, obviously, toward the public, with a handful of employees. So in BC, and this is something that I'll touch on with the others as well, the SkyTrain system is generally standardized because it sort of has to be, because the same train is going from station to station. But because they try to build an entire line, you know, simultaneously, they usually divvy the work up among several consultants, and as a result, the technology is fairly standardized. But I describe SkyTrain work as a pachinko machine of decisions, because you get this trickle-down effect of changes in the design, but they arrive out of order. And so we ended up having to fix things at the end in order to maintain that consistency. So airports. Obviously, airports can also easily exceed $1 billion. But again, much like with LRT, a lot of it is because of the civil engineering, not the technology or the buildings. So a lot is to do with the navigational aids, and then civil infrastructure like the runways, taxiways, aprons, ramps, storm drainage is another big one. And so you get these navigational aids like runway end indicators and you know, precision approach systems, these types of things. But you can also spend a lot of money on, you know, very specialized systems like EMAS, which is engineered material arrestor systems for when our planes run off the end of the runway. So for airports, the number of these technology systems is actually quite similar, but obviously they're very different technology systems because they're to do with flight information, baggage information, gate information, around the people movers and the CCTV there, because you have the same problem with people tripping and falling. You obviously have a lot of issues around things like security, keeping people off the apron, you know, keeping them in the terminal building, but also dealing with a fire in the terminal building without, you know, trying to minimize the disruption to the security. one of the issues I had with this particular airport is, the building authority wanted us to basically let everybody out of the building anytime there was even a hint of a fire alarm. But it can take, easily 2 hours to rescreen everybody to allow them back in to the airport. And you have to also screen, once you've released the security system in an airport, you have to basically check out the entire airport and everybody in it. So we really try to avoid that. So because the consequence of breach security is very high. So often I've found the technology systems are dealt with separately from the electrical system in airports, but obviously there's significant overlap between the two systems. So sometimes I'll do electrical, sometimes I'll do technology or communications or security. Prisons. I haven't worked on a billion-dollar prison. I don't really hope to. But again, from a technology perspective, they can be very complicated because you have very tight integration between systems like the CCTV, intercom, door control, intrusion detection, obviously. So they're actually I find them one of the more interesting systems. They also have obviously very high expectations on redundancy to make sure those systems work very high uptimes. And obviously, when we talk about the population and staffing, a prison's very different than a SkyTrain station or hospital. So one thing I will mention is that in new builds, the specifications for some of these systems tends to be performance-based specification, because that's the simplest way to allow for competition between systems that, for example, might be what I call fire alarm based versus SCADA based versus PLC based, because of this tight integration. So now let's get into some kind of specific examples around the hospitals, because that's what I'd always intended this presentation to talk about. One of the issues that came up for both Royal Columbian and St. Paul's was a discussion around using a conventional copper and fiber structured cabling system versus gigabit passive optical networking. So I will point out that in BC, we have a group called BC Clinical Support Services that's at kind of the provincial level. So in the States, that would be the equivalent of the state level, that sets a certain amount of standards. But it's important to understand that their staff are not mostly engineers or technologists. They're actually business graduates. So the way they come at the problem is a little bit different. So I used to always wonder about kind of the terminology they use, like stakeholder engagement and those types of things, as opposed to looking at it like an engineer for the technology. And it took me a while to realize that it was because of their training. So in large hospitals in BC, the local hospital has an affiliated BCCSS rep that is basically dedicated to that large site, or that and a few of the other major facilities nearby. But again, they don't tend to have a particularly technical background. Now, BCCS often does look specifically for an RCDD to be involved. But again, it's important to understand that even RCDDs have inconsistent technical backgrounds. And in this context, they tend to be contract employees. So it's very difficult for them to, be very innovative for these projects. So when it came to those technical matters, in my case, the engineer's opinion carried a significant amount of weight when it came to technology selection of these projects. So I should point out that when I did this, it was about 5 years ago. So things have changed a little bit, in the kind of structured cabling and PON world. But, I want to explain, in that context of 5 years ago, why we went with a mostly conventional copper. So what we had been told, of course, was that, PON can easily do gigabit and feed many ports passively. But the reality is that in passive optical networking, a bandwidth is shared amongst the many ports in even time slots. There are alternatives. There's what's called dynamic bandwidth allocation, and it can either be status reporting or non-status reporting. But regardless, it's not as efficient in terms of ensuring bandwidth as techniques like token passing. Because when we had our initial discussions with some of the people promoting PON, my assumption had been that it was a token passing system, but it turned out just to be time division multiplexing. So when you compare that to a switched 10 gigabit capable system, there's really, it's a very lopsided comparison. So in passive optical networking systems, you have to convert to copper at the ONT. I think they're called ONUs now, which is a powered device. So here's another problem with the hospital application. Hospitals have several types of power. They have non-essential from the utility. We have what we call vital, which is kind of the most important, delayed vital, which is a less important branch of essential power. Then we have conditional, which is even less important. As well, we have UPS, which is typically even higher priority. So you have, very easily 5 types of power. So if I have a powered device at the work area, I have to decide which one of those I would connect a particular ONT or ONU to. So, by the way, in America, you have similar systems because you have emergency, legally required, standby, critical operations, etc. So it's a similar problem. So obviously, in some applications, it's very easy to pick which one it's going to be in an admin area. Can easily be, non-essential or conditional, but it's a lot tougher in other department, like an exam room, because it can change. So one of the examples I used when I was asked to evaluate the system is I brought up back in the day, we had these 3Com IntelliJets. So these were also a powered in-wall Ethernet switch, which allowed you to bring one drop and create multiple drops. So they never really caught on, and there's several reasons. So one of the things that I say is those who don't remember history are destined to repeat it. Obviously, I remember these. It was very rare that we used them, but there's certainly a nice solution when you didn't want to put a switch on someone's desk. So another concern I had with passive optical networking is that, from my perspective, it's very similar to cable TV. And much like in cable TV, one of the things you'll notice about this particular splitter, and the reason that I picked this one, is that it splits the signal unevenly. So, and you can kind of do the same thing with PON and distributed antenna systems, but you do obviously get a loss every time you split. So in this case, half the power is going to one and a quarter is going to the other two. So, that's kind of nice, but it also means there's a certain amount of planning required around, how you're going to do the splits. So, again, why did I go mostly conventional copper? It's because in hospitals, areas are constantly changing. There's probably 2 or 3% of a hospital in any one year that's being renovated. So if I have a high demand device, like if one of the projects that I'm looking at right now is to add a second MRI to a hospital in an area that was previously just administrative. So if I have something like that, if I have a Cat 6A solution, that's very easy to accommodate. If I have something like PON, much more difficult to accommodate a very high bandwidth device that wasn't planned for originally. You also end up with situations like if you want power over Ethernet, but only in a handful of locations, you're again changing these ONUs so that they're effectively mid-span POU provisioning. Another concern is if you have these powered, active devices at every outlet, dealing with things like sterile areas when you want to make some of these changes is a real pain, because you've now distributed your problem all around the hospital instead of being able to work from the comm room. So for these projects, PON was ultimately relegated to kind of the administrative areas to ensure we didn't run into these conflicts around the bandwidth flexibility, quality of service, and things like that, and these power issues, because that's fine in an administrative area, because it's not going to be switched to diagnostic imaging, and if it is, it's going to be a major renovation, in which case we can just rewire the whole area. So it is important to understand that things like these diagnostic imaging information can be viewed all over the hospital, but they're not going to be viewed in something like an administrative area. So flexibility of the infrastructure was very important to us. So from my perspective, passive optical networking is similar to coax as a technology. It's what I consider to be an outside plant or internet service provider solution that's being applied to a LAN application. It's not to say it's not a good solution. It's just that you have to be careful how it gets applied. So in my case, because I've been doing this for decades, I've used solutions that are also coax, like 10-base-5, 10-base-2, IBM type 2 even, which is also why I understand technologies like token ring and how a slower token ring was actually superior to a faster Ethernet solution. So now what about some of the other systems that are used in hospitals? So one of the problems you have when you do communication systems in a hospital is you have many systems that actually effectively overlap in their capability and functionality. For example, if a nurse wants to talk to a patient, she can do it through the nurse call system. She can do it through an intercom. She can do it through wireless staff communication, et cetera, et cetera. So this makes it very difficult to specify specific systems because it actually will vary based on what the staff want, as well as, simple economics. So, and vice versa, when a patient wants to notify a staff member, that staff member may not be at a fixed location. So as a result, we have to consider how to notify someone that's mobile. So that can either be something like wireless staff communication, can be, just dome lights. That's another conventional way in nurse call systems. But we can also use things like overhead paging, which we'll do for code blue, which is cardiac arrest type scenarios. We've used scrolling marquees. We have LCD screens and corridors. So it makes it a real challenge to write a spec because, you have all these different options. So when it comes to introducing a new technology into a setting like this, I have to consider who the sponsor of the project is, who the users are, who's maintaining that system, and various other stakeholders, including obviously the patient. We also have to consider things like the cybersecurity aspects, like HL7 or HIPAA or FOIPA. So those are privacy, accountability type standards. So oftentimes I'll see people using systems that frankly I don't think are appropriate to protect patient privacy. So on the subject of specs, certainly here in BC, but also on projects like that airport in the Bahamas, these projects are not necessarily done as a design, bid, build type project. They're done as public-private partnerships here in BC or a design build. So here in BC, we do them typically as design, build, finance, maintain. But in other locations, I've done more complicated ones, which are design, build, finance, maintain, and operate. So there's a fixed period of time that the proponent actually operates that facility. Therefore, the specs tend to be mostly performance-based. So the specifications that we do as an owner's rep in that case is usually called an output specification, like the DCOS is Design Construction Output Spec, or a Statement of Requirements, an SOR. As the owner's engineer, I actually have very little control over the selection of individual vendors. And when I'm on the contractor side, the contractor is usually the one that's controlling the money. So they usually have the most influence over the supplier selection. When I am on the owner side and I'm writing an output spec, what I tell people is I have to envision a solution because otherwise you can't write a spec. But it's really hard to allow for innovation while defining those minimum objectives to meet. So how do I choose those objectives? It's what I call decades of experience and mind reading. Because one of the things I can tell you is clients rarely know exactly what they want in advance because the technology is constantly changing. And if they do know what they want in advance, it will only apply to a few of many of those systems and subsystems. So generally what I do is I try to establish a mission statement for my work as what I would call a guiding principles document. That way it allows me to revisit that and decide what my priorities are going to be, given that I have competing interests and a finite budget. So on the topic of copper and fiber for these facilities, one of the things I tell people is I've never recommended Cat 6. I went straight from speccing Cat 5e, over a decade ago, straight to, at the time, AMP XG, because that was before Cat 6 and Cat 6a really was formalized. But we already knew about alien crosstalk as being a potential problem going from Cat 5e to 6 or 6a. So the Bahamas Airport, Children's Hospital, Royal Columbian St. Paul's, they were all based on 6a because it does 10 gigabit Ethernet, the entire 90-meter standard distance. And when we have 23 gauge wire, that helps obviously in power over Ethernet applications. So generally, I should also point out I prefer screened or overall foil to internal pair separators and spaced jackets, because frankly, it's just more compact and simpler to work with, at least from my perspective. I don't spec fully shielded SDP because that's just not a North American thing. From a fiber perspective, it's pretty standard, OM3, OM4, sometimes OS2, because like OM5, while it's newer, to me, the benefits are really only for the backbone. And our backbones tend to be single mode. So from a connector perspective, I actually don't pick that. Those are usually standardized by the clients. We don't do stuff like interduct and bonded pairs and all that kind of stuff, because they're well, bonded ribbon cable very much, because that's primarily what you'll see in the data center world. So from the Wi-Fi side, at the time, again, 5 years ago, 802.11ac, now known as Wi-Fi 5, was what we did. We would just pull a couple Cat 6a drops in a regularly spaced grid in the ceiling, pretty typical. Nowadays, we would probably go to Wi-Fi 6, 802.11ax, and we may actually pull more drops too, because sometimes we do use the multi-radio access points. Personally, like at home, I actually have tri-band mesh Wi-Fi 5, but that's because I have a gigabit wired backhaul. And I haven't upgraded to Wi-Fi 6 because I just can't justify it with what I already have. Even when I'm doing stuff like video conferencing, working from home, because I have a wired gigabit, I don't really have any issues. What about PoE lighting? Because that's another trend. From my perspective, certainly here in Canada, we have the National Energy Code for buildings, or we follow ASHRAE 90.1. A lot of jurisdictions want LEED accreditation, so we already have very efficient lighting and lots of lighting control, right? One of the things I point out here in Canada anyway is the staffing isn't what I would call tech-savvy 20-somethings. They tend to be older and less tech-savvy, so they don't necessarily want individual fixture control. The other thing is, in healthcare, lights can often serve multiple functions. So a single fixture can have 4 different subsections. So you can use it as an exam light, a reading light, etc. And we want interchangeability in the fixtures because we want competitive pricing. The way lighting is done is the lighting suppliers try to create an entire package for the entire facility. So this makes it difficult to do things like the PoE lighting because they kind of end up being a little more challenging to include in the package. And we have those same 5 different branch of power issues. So something like PoE again becomes limiting because I have to use the most restrictive one. So I know it comes across that I'm very conservative, rather than being innovative, which I said we try to be. But the reality is that I try to treat it as not innovating for the sake of innovating. On the active network side, I have to consider things like VLANs, quality of service, all those wireless access points, because Wi-Fi is very important in hospitals. To a great degree on hospitals, the client, like BICSI Clinical Support Services, has a great deal of sway. In fact, they're the ones that usually purchase most of the equipment, although in some cases we actually do. But there's usually parallel networks in a hospital because things like the DDC, the mechanical control system, small goods conveyor systems, information metering, etc. Those are parallel networks to the hospital's real network, but they still need to be coordinated because it obviously makes sense to share certain things like the backbone, and they're going to be co-located in the same comm rooms. For these hospitals, the networks are what I would consider a collapse core. Like, we didn't have that mid distribution level. We went straight from the core to the edge, or access layer, whatever you want to call that. So another thing I wanted to touch on that I've seen a lot of consternation on is grounding and bonding. I always point out to people that unshielded twisted pair, and even the, like foil wrapped unshielded twisted pair, is balanced communication. Therefore, it doesn't reference ground. And obviously fiber doesn't either, right? So only coax systems and some unbalanced antenna systems tend to reference ground. So I was on the BICSI grounding and bonding committee. And even recently, I participated on a task force for high voltage grounding here in Canada. So I know a lot about grounding and bonding. I also did things like designing the lightning protection systems for Bahamas Airport, because they get a lot more lightning than we do here. So I know standards like CSA B72 and NFPA 780, which are the lightning protection ones, along with things like high voltage 142, 80, 81, right? So I always point out to people, for the most part, we're not grounding telecommunication equipment, we're bonding it, right? So as such, I generally resist excessive ground sizing, because it's really not being used. So another thing I want to touch on is what I call the devil's in the details. People often confuse, RJ45s as kind of, being Ethernet, or kind of migrating toward the Internet of Things. But I point out that there's 7 layers of the OSI model that we use for communications, and they're there for a reason, right? So just because it's an RJ45 doesn't mean it's Ethernet, doesn't mean it's PoE, and doesn't mean it's the Internet of Things. So we have, for example, nurse call systems with RJ45s that don't use Ethernet, and they're not a kind of star topology. They're daisy chained. So it's very common for people to assume that, they're getting, an Ethernet solution when they aren't. So I've listed a whole pile of the acronyms that I have in my world. And, on top of that, there's numbers like 802.11. So, I need to understand just a total alphabet soup. I often joke that my job's easy. You just need to know everything. So in terms of these pointers, from a salesman perspective, I often say you only get one chance to make a first impression. So I encourage people to be prepared, right? I tell people engineers want to know exactly how something works. An analogy I give is, one time one of my colleagues said that when you talk to me and you ask me the time, I tell you how to build a clock. And I said, that's not true. I just tell you how a clock works. So, I was taught that the key to sales is being relatable, knowing your product, and knowing its role in the greater system. So hopefully this presentation will help salespeople relate to engineers, and help younger engineers understand, how I did what I do. I've met many really good sales engineers, and I say that they know the obvious questions, but they also know the less obvious questions that they're going to be asked by a good engineer. I tell people that typical engineers see in black and white, good engineers see in gray, and really good engineers see in an infinite array of color. So I encourage you to, understand, your client's business, in this case, say the engineer, but also to understand his client's business, because, that's how you're going to be able to relate to him. So in summary, an engineer like myself may define the objectives of a specification. And, obviously they need to understand a whole pile of things, and they need to place restrictions on what people can and can't do. They ultimately don't have the final say on selecting a supplier, right? Although for some systems, I have specifically specified systems. They're typically kind of these what I call proprietary systems, like fire alarm or nurse call, which have to be integrated into like an entire hospital campus. And as a result, that integration capability is critical. So I'll also say it's a suboptimal use of both our time, bringing a canned sales pitch based on one product and trying to tell me that it's the most important thing I have to consider, because that shows, a lack of understanding of how many different things that I do actually have to consider. So yes, those systems can be important, but again, I'm juggling hundreds of priorities. So, and it's also important to understand that if you give me an example of, it working, very well at a different site with a different condition or priority, that, my job is to filter that and understand how applicable it will be to my situation rather than that other situation. So I have to be able to compare that site with mine and decide where in my site, that solution will work. There's a saying that when all you have is a hammer, everything is a nail, right? I have to effectively purchase specify an entire, workshop full of tools, not just, a hammer, right? So in conclusion, I hope you've all found this helpful in understanding, what the lead type of engineers on these large projects consider in order to help you understand how we make the decisions that we do for technology systems. And again, a huge part of that is I dig very deep into exactly how it works. And again, that's why I know things like token ring and orthogonal frequency division multiplexing and all these bizarre things, because I want to know exactly how it works. So that's what helps me decide, and that's how you can influence me, is knowing, those details, right? Because it will influence what I will or won't accept. So, I'd like to thank you again for, listening through this whole presentation. Again, I hope you found it helpful. If you have any questions, my understanding is you can just contact me directly. And thank you very much.